Okay, we are going to try to wrap up this notes page today. I'll tell you, once we finish this section, and we're going to practice this because we definitely need it, what is left in our book for us to cover is not near as difficult as this section. Okay, this is by far the most difficult stuff that we have left to cover this year. Okay, so we've been trying to match these formulas, trying to choose formulas, and here's the key with these ones that are a little more tricky, is we want to try to find a formula that's going to match the more complicated aspect of your integral, okay? And then we're going to make different substitutions that will help the rest of it match. And what happened with some of the problems from a couple days ago is we had this extra number that was kind of lingering, and we just canceled that number out by like multiplying by the reciprocal. Okay, so as we look at this problem, you're going to notice right off the bat, there, like our variable, like there's e's in this, the variable's in the exponent. It's not going to feel like any of the formulas on the front page are going to match this. Okay, here's what I want you to keep in mind with these problems. First of all, when you see an even number in an exponent, a 2, a 4, a 6, immediately say to yourself what that whole term is representing in your formula will likely end up being a p squared of some sort, okay? Could be a p squared of some sort here. Okay, the other thing that you just want to keep in mind is if we were trying to decide, well, what is the most complicated part of this integral? What the more complicated part of this integral is would actually be the denominator, because anytime you have a quantity, see how there's two things that are in this denominator, that kind of trumps the fact that there was just one thing in the numerator, okay? Now you'll notice though, in the denominator, see how the exponent on that e is not even? It's not a 2, a 4, or a 6. So when we're trying to pick a formula that's going to match, we are not looking for a p squared in this location. We are just looking for a p plus a constant, okay? This is going to represent a p right here. Okay, so let's go to the front here. Let me scroll there. Got our problem written. Okay, right off the bat, we can say for sure there are no square roots in this problem, so we are getting rid of any of these that have square roots in them. Okay, I will tell you the only formula that even had an e in it was this formula 21, but 21 in no way feels like it is matching this problem. So we are crossing that off. We are really looking for a p to be in place where this e to the t is. Again, we are just focusing on the denominator only because that is the more complicated aspect to this problem. Okay, so we got it narrowed down, 9 through 12, 15, or 16. Okay, I don't think it's going to be 15 or 16. See how these have p squareds in them? And we've been saying since this does not have an even exponent, that is not a p squared. So let's get rid of 15 and 16 from our options. 12 doesn't feel like that's a viable choice. Even 10 and 11 have like two quantities in the bottom. Number 9 feels pretty good here because that just has a p only, which we said that's what this is representing, plus a constant, which is what the b is. Okay, so let's try number 9 here. Okay, we're going to go back to where we left off here. Okay, we're going to write down that we're going to go for formula number 9. Okay, we're going to then write out formula number 9 generically as it appears on the front of the notes here. Okay, we're going to go ahead and write the left side and the right side, but I'm going to refrain from making my substitutions on the right side until I'm confident that after I've made the substitutions on the left side, that is going to exactly match what I've got going on here with my original integral. So let's decide on our substitutions, okay? We need to take the p out of this problem, and we need to replace the p. And I really am going to be focusing on the denominator at first, because that was the part that I was really matching, okay? So I'm focusing on the denominator right now. This p is going to get swapped out for an e to the negative t. Okay, that's what I'm going to put in place for it. As soon as I do a variable substitution like that, I'm immediately going to take the derivative of both sides. The derivative of e to the negative t is me copying that down and then multiplying by the derivative of the exponent. That's why you see I put a -1 right in front here. Okay, the other substitutions are my A, that would be the number in front of this E, which is just a 1, and the B, which also feels like that would be a 1 as well. Okay, so let's see if we can do these 4 substitutions on the left-hand side of our formula here. Okay, now keep in mind the P in the numerator is going to get replaced with an e to the negative t, and I realize right now that that's not what's there in the problem. There's a 2 there, but let's just see how this works out here. Okay, in the denominator it has AP, so I'm going to do a 1 times e to the negative t. Okay, I'm not even going to show the 1. Okay, then it says plus b, so I'm going to do plus 1. And then here's where things start to fall into place. You're going to replace this dp with an with a negative e to the negative t. Okay, now that's the left side of my formula. Okay, let's see if we can try to get this to match here now. I'm going to pull this up here in the numerator next to this other e to the t that we have. So if I have, this kind of got crossed off here, if I have an e to the negative t here, and then I'm going to slide another negative e to the negative t next to it, what I'm going to end up doing with these exponents is I'm going to end up adding their exponents. So I'm going to add those exponents together, negative t and negative t. That's going to make that negative 2t. And now let's see, does this feel like this is matching? Boy, this is really, really close to the original problem. You'll notice the only minor thing is there is a negative 1 here, and there's not a negative 1 in the original problem. So I want to counteract that by multiplying by a negative 1 in front, so that will cancel. I immediately, because I added that in and it wasn't there to begin with, I immediately have to come over to this side and make sure I'm doing the same thing to that side of the equation. I'm just going to put a big set of brackets then, and then I think this is matching great. So then we can go back to like the right side of the formula, that's this part right here, and we can go ahead and substitute. Every p is going to be replaced with an e to the negative t. Okay, so e to the negative t, every a is a 1, b is a 1. Okay, I'm just doing all these substitutions here, and then we're just going to clean this up. I am going to distribute this negative into both of these terms here. Okay, and that would be the answer for this one. Okay, let's look at the last one. The last one is actually very easy to pick out what formula you're using. If you look at this, you'll notice, yes, there is an e in this problem. If we flip back to the front of this notes page, that problem is a perfect match for formula 21. Maybe I should clean this up a little bit from when I had things marked up here. Okay, it is a perfect match for formula 21. Okay, so I'm going to go back to our problem here. I'm going to choose formula 21. I'm going to write out formula number 21 generically here. Okay, and you're going to see when you look at it, like, yeah, that definitely feels like that's matching nicely. Okay, the issue with this problem, you'll notice this problem is titled that this is a reduction formula. Okay, the reason it's a reduction formula is those last 3 formulas on that sheet, you'll notice those still have an integration symbol located on the right side of the formula, kind of like how integration by parts was, and then we still had to integrate that further. Okay, so let's see how this works. Let's make our substitutions. We're going to replace the p with an x, which means the dp is going to become a dx. The a is the coefficient in the exponent on the e. That's looking like on this problem that would be a 1. Oh, it looks like I skipped the n. The n is the exponent on the p, which would be the exponent on the x. That would be a 3. Okay, so let me make those substitutions on the left side here. Looks like we're getting Oh, I'm sorry, the a would be a -1. Grr. Okay, the a would be a -1. Okay, so that's going to look like that. Okay, that looks great. Okay, matches exactly. This problem matches the original exactly. Okay, so now I'm going to come over to the right side. I'm going to make those substitutions. Okay, all the p's become x's, all the n's become 3's, a's are -1's. I have this integration symbol though. Okay, now we cannot stop our prop. Since our answer is supposed to be the right-hand side, we cannot have an integration symbol here. We need to keep going until we can get to the point where we feel like we can safely integrate this section on our own. Okay, so let's clean up the right side. You do not need to write this left side anymore, so I'm going to move this equal sign over here. I'm going to clean everything up. I'm going to make this a +3. I'm going to combine this, so this is an x squared. And then I'm going to focus on saying, okay, I need to figure out how can I integrate this part here. Well, I'm going to draw a line. For me to integrate that, I'm going to need to apply formula number 21 again. Okay, I'm not going to rewrite out formula 21 because I have that written up above here. Here's the right-hand side of formula 21, but I do need to adjust what my substitutions are going to be. I'm definitely going to still plug an x in for all the p's. The a is still a -1, but this time, if you look at the problem, you'll notice the exponent on the x, see how originally it was a 3? Now it's been reduced to a 2. So I'm going to say the n is a 2. Okay. Now, what you're going to do is you're going to take this part right here that comes in front, and you're going to copy that down right here. Okay, and then when you get to the integration symbol, you're going to put a big set of brackets, and this is where you're going to apply the right side of formula 21 in for this part here. Okay, so I'm going, for the yellow part that I have highlighted, I'm using what I have bubbled in green up above, and I'm making these substitutions. Okay. Still have that integral sign, 2 minus 1. Okay, I'm going to clean this up. Now, get this. When I clean this up, I'm going to take this 3 and I'm going to distribute it into both of those. Okay? So that's going to be -6. I'm going to combine that to an x. Oops, I'm sorry. That should have been an x right there. Because I should have put dp equals dx over here. Okay. So as we look at this, we still have an integration symbol here, and that's not easy enough for us to be able to integrate that on our own just yet. So we're going to do this one more time. Okay, we're going to apply formula 21. Okay, these same substitutions. The difference, though, is now the n, that's the exponent on your x here, okay? The n is a 1. Okay, so all this stuff that is in front of what I highlighted in yellow, that stays. Like, you're going to keep copying that down in front here. And then when you hit what I highlighted in yellow, that's where you're going to put a big set of brackets, and you're going to apply all of the right side of formula 21 to what's in yellow there. Okay, so let's see here. Okay, I'm going to clean this up, and when I clean this up, I'm distributing this 6 in here. Looks like this is going to be x to the 0. That's going to cancel out, and I am running out of time on this. All right, we'll have to